Well, greetings, you super smart CP Chem students. This is the video that will take you through sort of the rationale behind the key that you guys were able to see for CFA 2.1. Based on scores, most of you probably just have some minor issues or minor misconceptions, or maybe just forgot how to find one or two particles, etc. This will take you through the entire CFA, why the answer is what it is. Okay, so in the first portion of the CFA, you guys were given this model, and in the model we have 8 protons and 8 neutrons, and if you 1, 2, 3, 4, 5, 6, 7, 8 electrons. So I'm going to write 8 electrons off here to the side. By the way, that little E minus is just a symbol for electron. Okay, so then it says, what is the name / identity of this element? And what we need in this case is a periodic table. Unless perchance you have memorized all of the atomic numbers for all the elements, which I doubt you have. Periodic table is going to be an essential tool for this exercise. And what we have to remember is right here in the nucleus, this is the part that tells us what the element is, and especially this number right here. At 8 protons means atomic number 8. And all we have to do is go to our periodic table, find number 8, and we will see that this is oxygen. Now, the mass, as you guys should have been taught in class, is simply taking our protons plus neutrons. So if I go 8 protons plus 8 neutrons, that makes a mass of 16 atomic mass units, so that is AMU. So this is, what will the charge be if the atom loses 3 electrons? So first of all, what is the charge in the way that it is? So right now, we have 8 protons and 8 electrons. So remember, that's like a plus 8 and a minus 8, so our charge is 0, the way it is written right here. But if I get rid of 1, 2, 3 electrons, that would now be 8 protons, which is a plus 8, and 5 electrons, which would be a negative 5, which would make an overall charge of positive 3 when I go 8 minus 5. So my charge would be plus 3. And then it says, what would be the charge if the atom gains 2 electrons? So in that case, 8 protons, which are positive, 10 electrons, which are negative. That would give me a negative 2 charge. And then if we add 2 neutrons, so instead of 8 protons and 8 neutrons, it would now be 8 protons and 10 neutrons. And for the mass, we just add those numbers to get 18 AMU. And then it says down here, which subatomic particle determines the identity of the atom. And again, that is what we did to answer letter A here. It is the number of protons that determines the atomic number. The atomic number tells you what the element is. Okay, so that is the one thing that we have to remember. So in this activity, we learned about isotopes, and we've learned about ions, okay, which are different varieties of the same element, whether it has a charge or just different mass. In this case, though, if we don't have 8 protons, it is not oxygen. So, for example, if that said 9 protons, that would not be oxygen, no matter what the number of electrons is, no matter what the number of neutrons is. If that said 9 protons, it would be some variety of a fluorine atom, some isotope or some ion of fluorine. Okay? Likewise, if it said 6 protons, that would be carbon. So that's the number of protons that determines the identity of the element. That is really important to remember, so I'm going to put some exclamation points there. All right. Now, all we're going to do for number 7, the final part here, is just put what we just did into practice. How can we quickly identify things? The mass number, the atomic number, charge of that element, or atom or ion. Okay? So, in this case, we are given a symbol. So for our first row across here, we have enough information in this particular symbol right here to quickly identify all the rest of the numbers. Now, let's do the easy ones where we don't have to do any addition or subtraction. Got to remember that this bottom number, it's our atomic number. Okay, so that is always the same as the number of protons. Okay, so for the atomic number, 56 protons. So that is also going to be 56. Now, the top number, at 136, that is our mass number. Okay, so remember that our mass number is equal to protons plus neutrons. Okay, so that means that this total mass is equal to the number of protons, which is 56, plus whatever that number is. So a really quick way to figure that out is neutrons equals mass number minus atomic number, or mass number minus protons. So in this case, we would go 136 minus 56, and we should get 80 for our number of neutrons. Okay, and for our number of electrons, that is going to be, remember our charge, so we have a charge of +2. Okay, so this is a barium ion, not a barium atom. Okay, so in this case, we have a +2 charge, so that means that the combination of our protons and electrons equals our charge. So we can just quickly go protons minus charge. So in this case, that would be 56 minus 2, because that's a positive 2. We should get 54. Excuse me. Okay, so the same exact reasoning applies for the rest of this table. Here, we could probably look at our number of protons to get our atomic number, because those are always equal. Okay. Here, we'll notice that our number of protons equals our number of electrons. So if charge equals protons minus electrons, that's 25 minus 25, 0. So that means we're going to have no charge, and we're atomic number 25. And so if we look that up on our periodic table, we would see that that is manganese, M, N, and atomic number 25. So we know that much of this symbol already. We also know that we do not need a charge up here because there is no charge. Okay, our mass number is 56, so that goes there. So we have now finished that symbol. All we have to do is quickly find the number of neutrons by going 56 minus 25. And we should get 31 for our number of neutrons. Moving on, we have atomic number 79, so number of protons, 79. We have 120 neutrons, so I'm gonna, for this one, I'm going to have to go 120 plus 79 to get 199. And atomic number 79 on our periodic table is gold, given the symbol Au for its Latin name aurum. Atomic number 79. Mass 199. And again, the proton number and the electron number is equal, so no charge. All right, last one. Number of protons is 20. That makes this calcium, by the way. That makes atomic number 20. So real quick there, we have 21 neutrons, 20 protons, so 21 plus 20 makes 41. So we're going to go 41 and 20. Okay, so it looks like we're almost done except for this number and this number are not equal, which means we have a charge. 20 minus 18 equals 2. That is a positive 2. So I've got to remember to put that 2 plus up there in that corner of that calcium ion.